Example 2. Consider a project that requires an initial investment of $27,000 today. If you expect a cash inflow of $45,000 at the end of year 4, what is the IRR of this project? If your cost of capital is 11%, should you accept this project based on the IRR rule? Okay. So we're dealing with the internal rate of return, the IRR, and the decision rule is simple. If the internal rate of return is greater than the cost of financing the project, then you should accept the project. Okay? So, example 2. The timeline is very simple. We have $27,000 at time 0 and $45,000 in year 4. Okay? And first, we want to calculate the internal rate of return, IRR, and we're given the cost of capital. We'll just call it WACC, 11%. Okay? So we can first find the IRR of the project, and we can do this two different ways. First, we can find the discount rate, find the R that makes the NPV of the project equal to 0. The NPV equal to 0. Second way is just calculate the rate of return from this project. Remember, these were the definitions of IRR. There are two definitions. The internal rate of return is the R that makes the NPV of the project equal to 0. It's also the rate of return generated from the project. So we'll do this both ways. So we'll first calculate the NPV. The net present value of the project is the present value of the first cash flow. It's already in year $0, so that's just that. And we have to add the present value of the second cash flow, the $45,000. Okay? So we'll take the $45,000 and discount it using R, and it's raised to the 4th power, and we're gonna set this equal to 0. Okay? So using the definition, the first definition, we're looking for the R that makes the NPV equal to 0. Okay? So we'll solve for R. So this $27,000 plus 45,000 over 1 plus R to the 4th power is equal to 0. So we're going to move the 27,000 over to the other side. Let me just make this. So this becomes 45,000 over 1 plus R to the 4th power equals 27,000. Okay? So we're going to get 1 plus R to the 4th power by itself by multiplying both sides by this and then dividing both sides by this. Okay? So 45,000 over 27,000 equals 1 plus R to the 4th power. From here, we got to get rid of the exponent. So we're going to take the 4th root on both sides, like that. So if you remember your math, it's the same. That's the same thing as raising both sides to the 1/4 power, basically. So this becomes 45,000, 27,000 raised to the 1 over 4. This equals 1 plus r. Okay? And to get r by itself, we just deduct 1 on both sides. So the r that makes the NPV equal to 0 is then 45,000, 27,000 raised to the 1/4 power minus 1. Okay, so this is the IRR. Again, it's the r that makes the NPV equal to 0. Okay, so the IRR is 13.62%. That was the first method. The second method is a bit easier, so we're going to use this second definition. The IRR is the rate of return generated from this project. That is, if you put in $27,000, you'll get $45,000 in year 4. Okay? So we know a formula from before. It's the rate formula. Rate given the present value and the future value and the number of years is equal to the future value over PV over raised to the 1 over nth power minus 1. So you just have to be careful. This rate, we use $45,000, but for the present value, we want to put in a positive number, even though the $27,000 was a cash outflow. Okay, and 1 over 4th power minus 1. So if you look, we have the same expression as before. Okay? It's just how the formula is derived. Okay? That is 13.62%. So the same answer. So the IRR is 13.62%, and the problem asks, if the WACC is 11%, should you accept the project? Okay. So the decision rule was, if the IRR is greater than the WACC, then you accept. That's because IRR represents the rate of return from the project, and the WACC represents the cost of financing the project. It's the weighted average cost of capital, right? So if the return is greater than the cost, then you accept. And that's true in this problem. It's greater than the WACC, so you should accept.